Welcome to this video. In this video, we will discuss half-wave rectifier. So, what is a rectifier? Basically, a rectifier is something which converts a AC current or a AC current into DC current or a fluctuating current into a direct current. So, fluctuating it is not like a non-directional current into a unidirectional current. That is what basically it means. So half wave means, as I know, in AC current consists of two half waves. One is one positive half wave and a negative half wave. That is called one cycle. So we can say positive half cycle and negative half cycle. So a half wave rectifier only that means transmits only the positive half cycles, or either positive half cycles or either negative half cycles, and all the negative half cycles are cut out and the only positive half cycles are passed, the current is passed. But even though the current is flowing in one direction, that is in positive direction, but there is some discontinuity between two half cycles because all the negative half cycles are cut out. And such a circuit is called as half wave rectifier. This is just a primitive, it doesn't practically used anywhere. Just to understand the concept, we use this diagram, and it is not at all used anywhere, and it is just to understand what is the concept. So now here it basically consists of a diode, because as you know, the basic property of a diode is that the diode conducts current during when it is forward biased, and diode does not conduct current when it is reverse biased. So what is that? Because a P type of the diode is connected to the positive terminal and N type is connected to the negative terminal, which is called as forward bias. So in that case, the current flows through the diode. And suppose in the reverse case, where we connect the P type of the diode to the negative and the N type is connected to the positive, the current is not passed through the diode, or the diode does not conduct the current. So in a AC current, what happens is every time this polarity changes every half cycle. So that depends on the frequency or time period of the AC. For example, in India, the AC frequency is 50. So that means 50 hertz. In 1 second, 50 times this polarity changes in a current. That is what happens in a current. In whatever the current which is flowing in your houses, you understand that in 1 second, 50 times the polarity of the current is changing. That is what we call as AC current. And this AC is what happens, is used commercially and every houses and all. That is what supplied. So this consists of an AC supply, and the AC supply is passed to the connected to the step down transform, because the voltage will be very high. I want only 4 volt or something like 5 volt. I don't want, because the AC supply is 230 volt and I want to step down, decrease the voltage from 230 to 5 volt. I use a transformer, and then the transformer is connected to a what I say is called as a diode. So what I do is I connect the P type of the diode to the transformer secondary circuit, and then I want to limit the current. I use a resistor or load resistor where we are measuring the voltage or the current. So now what happens is, during the positive half cycle of this input AC current or AC voltage, what happens is the voltage, the diode will be forward biased. And that case, the current flows through the diode and the current will simultaneously passes through this load resistance. So if I measure the current across this load resistance, what I get is a current like this at a discontinuity between each half cycle. So there is no current between one positive half cycle and the second half cycle, positive half cycle. So this is what look like an output of a half wave rectifier looks like. So this is how basic construction and principle and working of a half-wave rectifier. Now we have to understand the frequency. What will be the frequency of this half-wave rectifier? There will be no change in frequency, because whatever frequency the input is giving, the same frequency the output will be. Because as I know, in input AC current, there will be two half cycles, one is positive and negative half cycle. But in output also, there is only one half cycle during the positive half cycle, but there is no current in the negative half cycle. But the second positive half cycle starts only when the second cycle starts in the input. So there is no change in the frequency, because the same time when the second half cycle in the positive half cycle starts in the input, we are getting a positive half cycle in the output. So they are simultaneous in phase and there is no change in frequency. So whatever the frequency is in the input AC current, the same frequency will come in the output AC current also. Now, when we come to the efficiency of this halfway rectifier, basically what is efficiency? We just divide the output of something divided by input of something, that we will get the efficiency. Whatever you are getting, that you divide that by whatever you are giving, that is what the efficiency. So here in this rectifier, what we are getting a DC current. DC current means it will produce a power, the DC power. So when we are measuring some efficiency of someone, you have to divide the energy of the output energy divided by the input energy. So here the energy or the power in this case is basically the power which is passing the power due to the DC current which is passing through this load resistor, and divide by whatever the input power you are giving through the transformer. So now, how to understand this? This concept is what we have to understand in this case, because the next time we will understand full wave rectifier, bridge rectifier, which are in practice. Now, that I am using by a mathematical treatment. What I am doing is I am analytically what I am saying is this is a varying current. So it is quite difficult to find the average of something when it is something varying. So if something is constant or in discrete, it is very easy to find the average. If I am having some numbers, and if I have some height of some 10 people, it is a discrete quantity. You just add all the heights and divide by 10, you will get the average height. But here the current is continuously varying and it is changing, it is not constant. So in such cases we have to use calculus or integration to understand to find the average of some quantity. So you see here the input current is like this, where I am having a continuous current or voltage throughout the full cycle, and in the output I am getting only the current in the first half cycle, but they are proportionally the current will be somewhat lesser in amplitude than the voltage, because there is some resistance in the circuit. So whenever I'm getting a sinusoidal variation of something, I use a formula, which is an equation called as something like the amplitude into sine theta will give you the expression, mathematical expression for something which is varying sinusoidally. So we used to say that an AC current is always sinusoidal. You can use a sine or cos to represent an AC variation, an AC voltage or AC current. So I am using a Vm sin theta to represent the input AC voltage, because it is a perfect AC voltage. I am saying the instantaneous AC voltage is Vm sin theta. Now there are two resistance in the circuit. One is the the diode resistance, the resistance of the diode itself, and second one is the resistance of the load. So the total resistance will be RF plus RL, and the diode conducts only due to the positive half cycle. So now we come to the average DC current. Let me find the DC output power. For that, first of all, I want to find out the average current, because average current will be DC, because even though the output is varying, pulsating DC, because even though it is unidirectional, it is not constant. It is a sinusoidal variation of current, even in the positive direction. In such cases, I want to find the average by integration method. Now I see that this is taking place over the varying over a angle of pi, because one half cycle is pi, because one full cycle is 2 pi. So what is varying? The current is varying. The current is varying throughout an angle pi, which is I d theta. Then I want to find the total current, that is 0 to pi. That means divided by I d theta. I want to take the average over one cycle. One cycle the angle is 2 pi. So I divide by the total angle, which is 2 pi. So what is the average current? The average current is 0 to pi I d theta by 2 pi. Now, what is I? I is nothing but the current. How to find that? That is the voltage by resistance. So I divide the instantaneous voltage, which is input voltage, that is Vm sin theta, which is the maximum. Vm is the maximum voltage. Then Vm sin theta will represent the instantaneous voltage, and I divide by the total resistance. And then I take everything constant outside the integral. I am integrating this sin theta. Integral of sine theta is minus cos theta, and then I put the values of the limit minus cos theta 0 to pi. That will give you 2, because cos pi is minus 1 and cos 0 is 1, and there is a negative sign also, so that will become 2. So now what I get, the average current is 2 Vm by 2 pi into Rf plus RL. 2 and 2 cancel out, so we will get Vm by Rf plus RL into 1 by pi. So Vm by Rf plus RL is nothing but the instantaneous current. So Im by pi is the average current or DC current. Now what I do, I find the output power by finding the DC power of due to this current. I have the DC current, that is average current. Even though the current is not constant or it is pulsating, I have found out the average of this pulsating current over a full cycle. Then I use that equivalent average current to find the DC power, which is I square DC, I square into RL. So Im by pi the whole square into RL, that is the DC output power. Now I want to find the input power. Input power is nothing but AC power. AC power is very simple, because the current of an AC is generally represented by the RMS value of a current. RMS value. RMS value represents the average equivalent DC current of an AC current. So if I have an AC current over a full cycle, in one cycle, what is an equivalent DC current or equivalent average current of an AC is simply just the RMS value. So RMS value is basically given by Im by 2 for a half rectified wave. So Im by 2 the whole square into Rf plus RL will give you the input AC power. Now I can find the efficiency. Just divide the DC output power by the AC input power. I have found out the DC output power, that is Im by pi the whole square into RL, that is the DC output power, divided by Im by 2 the whole square into Rf plus RL. Im and Im cut out, we will get 0.406 by 1 plus Rf by RL, which means that the maximum efficiency of a rectifier is only 40.6%, because it is obvious that half of the cycle is not being present in the output, is lost. So that means the efficiency is lesser than 50% or 40, only 40%. That means you are wasting the negative half cycle in this rectifier. So 40% of the AC power is converted to DC power in this half-wave rectifier. So one more factor we have to understand is a ripple factor. So ripple factor is basically the amount of AC component by the DC component, that we will discuss in the next video. Come to the end of this video. Thank you.